In this unit, we're going to be talking about congruent triangles, ultimately. And so we want to back up for just a little bit and remind you what you know about congruent figures. So congruent means that all the sides, or congruent means that the measurements are the same. And so congruent figures means that all corresponding sides and all angles must be congruent. That goes for any shape, for quadrilaterals, pentagons, any polygon, including triangles. So we'll use an abbreviation called CPCTC. What that means is corresponding parts of congruent triangles are congruent. And when we say corresponding parts, we mean the sides, the pieces that match up. So all three angle pairs will match up, and all three angles or sides will match up. And then there's a third angles theorem. The third angles theorem really is just kind of common sense when you think about it, that when you have two congruent triangles, so if I have two triangles that have, say, a 30-degree angle and a 45-degree angle, now these are not going to be drawn to scale, a 30-degree angle and a 45-degree angle, and this one has a 30-degree angle and a 45-degree angle, that because those two angles are congruent, it is safe to assume, I can assume that these third angles are congruent. And in fact, I don't even have to assume, I can calculate it, that 30 and 45 is 75, which means that this angle has to be 105. Well, that also applies to this triangle. So it's just understood that if two angles of a triangle are congruent, then the third is, and you don't have to find it. That's kind of the point of the third angles theorem. So let's look at what we talk about, what we're meaning by corresponding parts. So you can tell by how these angles and sides are matched, or how they're marked up, which ones correspond, because sometimes you can't tell when the shape has been flipped around or rotated or reflected. And so it's important to either use the congruent statement or use the way that the drawing is with the markings to match everything up. So the corresponding angles would be that angle K is congruent to angle S. You can see because they have single marks. You have angle L is congruent to and corresponds to angle R. And then angle J is congruent to angle T. Then when we match up our corresponding sides, the order that you say them in matters once you get started. So say, for instance, I say KL. Then KL is congruent. So if you look at how we did KL, KL went from the one mark on the angle to the two marks on the angle. I'm just using the angles to go in the same order, and then I'm going to match that order over here and do SR. So KL is congruent to SR. I've got KJ is congruent to ST. And then I've got LJ is congruent to RT. And so I'm trying to use them, how they're matched up with their angles and the vertices that they're at, and so that everything matches up in the right order. Now again, it doesn't matter. I could have said LK, but if I said LK, I would need to say RS. So it doesn't matter which one you start, but once you pick a direction, you need to stay that direction. So a congruent statement for this triangle, I could say then that triangle KLJ is congruent to triangle, and again, order matters. You need to match up the pieces, SRT. And it doesn't matter how you start. I could say JLK, but then I would need to say TRS. So just once you pick a direction, stay in that direction. So we can use this to solve these two pieces. If we know information about one, then we can know information about the other. The statements are important, so you need to pay attention to that, because especially with rectangles and squares and triangles, sometimes it's hard to see how they're oriented. So if you look, we can see that KL matches with PQ. So if we look at our statements here, then angle N, right here, angle N matches with angle S. So you can mark that in your picture. Angle N matches with angle S. Sometimes I just find it's easier to mark it on your picture, or you can mark it here. Angle N is congruent to angle S. Angle R, which is right here, is congruent to angle M. We can use the congruent statement to find that. So angle R is congruent to angle M. KL, these first two. KL is congruent to PQ, and LM is congruent to QR. So KL is congruent to PQ, LM is congruent to QR. So in these next ones, I want measurements. Congruence goes with pieces and equal signs go with measurements. So the measure of angle P, then the measure of angle P, if K matches with P, we can see by our congruent statement that K and P match up. So that means that angle P must be 88 degrees because that's how big angle K is. Angle L matches with angle Q, and angle Q is 92 degrees, and so angle L is also 92 degrees. And then KL is 2x plus 5, and actually it matches up with PQ, so we know that before we even solve for x, we know that KL has to be 22 because that's how long PQ is. LM has to be 18 because that's how long QR is. And then we need to find x. Well, KL was actually labeled as 2x plus 5, and it should equal 22, so we want to know what value of x gives us that. Subtract 5, 2x is 17, and you get that x is 17 over 2, or 8.5. Okay. So in this diagram, QRST is congruent to WXYZ. So if WX is y plus 1 over 2, and QR is 3 minus y plus 2 over 5, RS is 5, and ST is 3. So obviously we want to be solving for x and y, and so you need to find your matching pieces. So to solve for x, I need to use that 5x plus 5. I think it's easiest to use the congruent statement instead of the picture because you can see that this one has been flipped over in the x and the y direction. And so to keep everything straight, I think it's easier to look at the congruent statement. So we've got W, and W matches with Q. So Q is right here at 65 degrees. So X then would be 5X plus 5 is equal to 65, or 5X is 60, or X is 12. Then to solve for Y. If we solve for Y, again, I think it's good to use the equation. I want to solve for y, so pick one of the y's. Y is QR, so QR matches with WX. So those two are going to equal each other. So we have 3 minus y plus 2 over 5 equals y plus 1 over 2. I think it's easier when you're dealing with fractions to go ahead and try to get rid of that fraction. And the easiest way to do that is to multiply by your least common denominator on both sides. So 3 is over 1, and then we have 5 and 2. So 10 would be our least common denominator. So if I multiply by 10 on both sides, and then distribute, don't forget to distribute and be really, really careful here. You might put parentheses around that y plus 2. We have 10 times 3 is 30, and then minus 10y plus 2 if you want to write out that step so that, oops, actually made a mistake. Gotta go back. It's 10 times y plus 2 over 5. So when you distribute that 10 over here, this 5 and this 10 are going to cancel out, and you're going to be with 2y plus 2, but don't forget those parentheses still. And then the same thing happens here when you multiply this 10. It's over 2. Everything is over 2. So this 2 cancels this 10 down to 5. So it's 5 times y plus 1. Now you've got all your fractions, and so this is much easier to deal with. So we have 30. Don't forget to distribute the whole negative 2 both times. Equals 5y plus 5. So I'm going to combine my like terms. Add 7y to both sides, subtract 5 from both sides. You get 21 is equal to, oh, I went to 7y. It should have been plus 2y. Plus 2y, I skipped ahead to get 7y. Divide by 7, and you get that y is equal to 3. So use your be sure you use your congruent statements to set up things so that you can be sure that because a lot of times you'll be given extra information and you want to make sure that you have it. So right now, in order to tell that figures are congruent, we need to know that all the corresponding parts are congruent. And so we can use this proof to prove that those two triangles are congruent. And so the way we would do that is we'd start with our given. E is the midpoint. Now, I like to split this into pieces. So I'm going to show you. So E is the midpoint of AC, and so we know that that's given. Now, in order to prove that things are congruent, we need sides equal to sides and angles equal to angles. And so whenever you have givens that are words, then it means that we're looking for something congruent to something. So I like to split this up so that I can make sure that I use all of my givens. So if E is the midpoint of AC, it means that AE is equal to EC. So I would say AE is congruent to EC, and that's because of the definition of midpoint. Now, I know I haven't used all of my given yet, and it's okay, I'm going to go back. So that's an angle. So I have an angle congruent to an angle. And remember, I need 3 sides congruent and 3 angles congruent. So then I can say this second part. So I've used this part. E is the midpoint. Now, again, it doesn't have to be this way. I just like to make sure that I use everything, and this helps me do it. So that's given. And so if E is the midpoint of BD, that means that BE, oh, sorry, I caught this, that's a side congruent to a side. Hopefully y'all caught that. We're like, nuh-uh. BE is congruent to ED. And that's the same reason, definition of midpoint. Again, it could have been written all in one statement, so you could only have 2 statements at this point if you wanted to. So that's another set of sides. Then we need our third set of sides, which we actually have. It was labeled in the picture and it's given in the statement. So AB is congruent to DC. That's given. So now we have all of our sides are congruent. Now we need to know that our angles are congruent. So if we come over here, we look at our angles. First thing I notice, and this may be may not be the first thing you notice, but I notice that these 2 lines are parallel. If those 2 lines are parallel, then that means, and we need to state that, we've got that, our statement right here, AB is parallel to DC, and that's given. So that means we need to use those parallel lined postulates and theorems that we learned earlier in the year. So if those lines are parallel, then that means that angle A is congruent to angle C. So I know this is congruent to this. I also know I can use that same set of lines, and I'll just kind of skip a step here instead of doing this on 2 lines. I also know that if those 2 lines, I've got that transversal too, and for the same reason, I got angle B is congruent to angle D, because if lines are parallel, alternate interior angles are congruent. Remember, we knew the lines were parallel, therefore we can talk about the angles. So that gives me a set of angles and another set of angles, and I need one more set to be able to prove that those triangles are congruent. So using the information that I have, I also know those vertical angles are congruent. So I can say that angle AEB is congruent to angle CED because vertical angles are congruent. You could also, once you have 2 of them, you could also use that third angles theorem if you wanted to. And then 9, we've got all of our angles congruent. We've got all of our sides congruent. Therefore, that means that I can say that triangle ABE and triangle CDE must be the same side. And that's because corresponding parts of congruent triangles are congruent. So if the triangles are congruent, if all the corresponding parts are congruent, then the triangles are congruent. So you want to use the congruent statements. We're going to find out we don't actually need those 6 pieces of information. We don't need all 6 of them. And we're going to talk more about that later. But right now, just pay attention to your congruent statements. Always make sure that you use